Okay, I guess we can start, right? Everyone back? All right. So we had a few technical problems with Parquet files. So welcome back, everyone. While we had our lunch break, I was trying to add some extra functionality on extracting, for example, defendant's name, right? It'd be nice to extract that, but it's not so straightforward. Why? Because it's not always, does not always exist, basically, right? So if you want to do this, you have to extract person's name, and then you have these interpretations of the gender. We only know that the first defendant was a male. We don't know his name. We don't know his surname, right? If you look at another one, here, second one, right? Victim has name, surname, and a gender, for example, right? So this is a very common occurrence when you're dealing with partially structured data. Well, some attributes, some features might basically just not be present. So usually, of course, you do what you do. You just give an empty string or something like that. So you have to account for that when you're making your extraction function. So yeah, it's possible to get this. I'll show you a little example before we move on to next notebook. So I could find the person name. This is defendant because they have type, right? And first instance of that, again, if you want to find second, you have to find all. But this at least finds the first one, right? There's always going to be one defendant. But then if you look at you find the internal tags here. You see here, where is my first defendant, right? I mentioned he only has jurors, and we start here. Okay, proceedings can start, right? And yeah, so only gender is present, right? So you see, if you write person name tag, inside the person name there's interpretation tag, which has only its gender type, right? So we can extract that, but you'd have to make your function maybe a little more flexible, provide non-value or empty string if it's does not exist, right? So that's quite possible. But okay, but let's move on to our next notebook. And the good news is that our AI assistant should be helping me, hopefully. All right, so day one, loading. Right. So I'm going to open two processing. So it's going to involve tokenization, meaning dividing into some tokens or text, maybe stemming, lemmatization, maybe some other format to make it more digestible for our analysis. One thing we might want to do is we want to maybe remove punctuation. Again, if you're not studying punctuation, probably it's not going to help your analysis. Also, you might want to convert text to lowercase. Why would you want to do that? I mean, why do you want to convert John or Alice to lowercase? Well, for John or Alice, it might be, it's always John or always Alice or Bob, but for some regular words, if they're at the beginning of sentence, of course, you want them. It doesn't, the word is there, whether it's a beginning sentence or middle of sentence, right? Normal world, not proper, non-proper words. Words, if you're talking about English or maybe Latvian, right? You want to consider them all in the same bucket. They must be in the same bucket. Okay, so this is second day. So not first day, but second part. Again, if you are on using a Colab, right? So you should be able to go here, click on second part here. Right, and open it up, and connect. Let's see if this works. And let's check our libraries, if Colab works. I have not tried this on a Colab lately, but it should work. It worked before. Pandas works, and Spacey, which is a natural language library, should also be present. Okay, there we go. All right, so we'll be using a CSV file. I personally would be usually use a Parquet file, but I know not everybody got the Parquet working, so let's use CSV. Again, the downside to CSV is that all the data types are gone, so you have to sort of like infer the data types. So pass, counter, Counter is something for counting things, obviously from standard library, regular expression, string, timestamps, pandas version. Let's see. Let's do this. F. Yeah, okay, you see this here? I typed F, which is string formatted, a quote, and P, and the rest is done by Copilot, right? It knows what I'm trying to do, right? I've done this many times. So why does this work? Well, I've provided some examples before when I do this. So Copilot machine learning model, well, it has a context, right? So it will offer this. So all I have to do is press tab, and I don't have to type anything else, right? So it's a real time saver. If you do many similar things over and over, right, it will offer something very similar. So this, I don't know, it saves maybe 4 times as much time, right? If you type similar things, I mean, it's just nice to have. So same thing here. So what do you think will happen if I do this? So print, you see, I didn't have to do anything, you see? I only pressed P, right? And it already knows. It infers, right? It's trying to predict next token, so it knows there should be a print, there should be f string, and there should be a spacey version. Why again? Because I did pandas version, so it can make very good this model, this GPT model. I think it's based on 4.0 right now. Actually, it can make very good inference. What I'm trying to do, right? So quite nice, right? So in effect, of course, I mean it's nothing I could not do before, but it just saves me so much typing, right? We all want to preserve our hands, right? So very good, very nice to have, right? So I could also import some other libraries. What else could I import here? I don't think I need anything else here, but let's take a look. Let's run this. And what versions do I have? Pandas 2.22 and GenSim, Spacey, sorry, Spacey. Spacey is a language library. It's very nice, but the bad thing is for those who are studying like Latvian language, it does not have very good Latvian support, unfortunately, for Latvian specific tools like for stemming, for lemmatization. This is something to do for, I don't know, somebody to do. Lithuanian has better support, right? It's just, it's volunteer, it's open source library. So for English, it has very good support. That's why we're using it here today. For Latvian, we have to use other tooling, unfortunately, right? So again, to make things same for everyone, we will be using CSV. But what we'll do is we'll use Pandas built-in read CSV function. And what's so nice about Pandas read CSV function is it includes the requests. So basically, you can provide a file name or you can provide the URL, right? So it should work with URL. Right, so very nice. So let's see if this works, of course. Big question. So it should work for everyone on Colab, on locally as well. So it goes to this address, and it's a CSV file. And let's take a look what happens. It should work. It has to make a web request to this address, and it worked. So 1600. But what happened here? I don't have my file name. Did I not save it? Or did I overwrite? Where did because I did not submit it right. Okay, but that's okay. For this purpose, the extra feature is not present in the GitHub repository. Remember, I made the file name, right? But that's okay. We still have the year, so I'm not gonna. I could upload the other file. Do I have it actually somewhere here? Let's take a look. Maybe I have some other location. Maybe I could also. Let's see. Do I have it locally? Right now, if you are opening a new Colab, of course, you won't have the old file unless you save it somewhere, right? For Colab, right? Where's my Colab, right? Thing is, right, you have only sample data. Again, you have a new fresh notebook, right? You only have start with a new blank tabula rasa, sort of blank state. If there is a way to link your Google Drive, by the way, here, you could do that as well. It's possible. But for us to make everybody on the same page, we use the same link, right? Let me see before we move on. Let's see if I have the one temp. I think I had it in temp folder, right? I know what the story is. On CSV, this one is not a temporary folder. I have excluded from my Git repository. I have an exclusion, so because this is just temporary files, so it's not submitted as a file. Okay, so what we can do is, let's see this. Let me see. Yeah, so this has it. Okay, so what do I do? I could do this Control C, and it is under date, I believe, right? Yeah, I'll copy it here. Yeah, and now, right? Changes. I'll upload. Added file name to CSV sample. Yeah, and let's take a look. So take me about synchronization with a GitHub server. Now it should work. Give me the new one. Assuming internet works. Yeah, it worked. So we can check our repository and see if anything happened here. Let's take a look. So just now I expect data now added file name to CSV sample. So the new version is present here. You should be able to see this, right? I'll show you the data. Yeah, it is present here just now, right? There it is. So we should be able to load this. If I do it again, I should be able to see this, right? Yeah. Let's take it again. Let's try it again. It's a copy, yeah? Yeah, you're right. Did I really commit it as a copy? Oh, that's too bad. You're right. It's a copy. Okay, well, we have two things we can do. We can just basically just change the name, right? I could do this, right? I could do copy, right? Yeah. Well, yeah, you're right. Very good catch. So I will do this, but of course I could just overcopy. This is not... obviously, if you're using a Git bookkeeping, there's no really need for copy. This is something if you don't have Git bookkeeping, then you have copy of a copy of copy of copy, right? But you should try to avoid this. But now I should be able to have, okay, and there's no valid US URL because there's a space. Let's take a look at this. What's the name of it? Copy. Yeah, that's not cool. Right, so what I'll do is, I'll fix this. Okay. I'll fix this. Not a good commit, but that's okay. So data, yeah, there's a copy, right? So what I'll do is this. I'll delete it basically. Delete. Yeah. And again, if you're under. Oh, here we go. Right. On this one, I will get rid of the copy. F2, right? Now it should be correct. Okay, now let's take a look. So yeah, so this is deleted and this is present, move change. Okay, updated old Bailey's sample. So to do this synchronization, you need to have a Git installed, and of course you need to have the authorization on that Git repository to make the changes. It's possible to have multiple collaborators on the same Git repository, but of course you need to have the rights to make upload. You can download, if it's open, anybody can download this clone or pull the changes. So now I'm hoping it's correct. Let's take a look again. Copy is gone. Again, great. So let's try it again. One more time. Okay. Copy. Yeah, bad URL. Finally, please, let's let it work. Yes. No. Okay. So where did we go wrong? Presumably, it's still the interesting. Well, it's not the end of the world. I still want to fix. Let's see. What did we do that we copied incorrectly? We have the sample here, right? This one? Yeah, this is what we want, right? Control C. Looks correct, okay? Now, this one, we want to copy it here, data directory, right? So here, I'm going to overwrite. It made the copy, okay, Control Z. So what, yes, what I'll do is I'll get rid of it. I don't know, for some reason. Yeah, for some reason, one do more time. It's because I have one more time. Now it looks correct, right? data, it's present. Now, but why does it say that it's not? That's strange. Maybe, I know it could also be, there could be a caching issue. Maybe it's downloading the old file. It's possible. Let's double check again. It looks like it's all fixed already. It started working? Yeah, it's a caching issue. Very common in general in data working. If something doesn't work, check if you're downloading the old version. Right, with web page, you've seen this, right? There's something refreshing, right? So it looks like there was a cached version. So I'm not quite sure. It's probably GitHub giving you the old version, assuming, or it could be Pandas, maybe thinking, okay, you just download this file. You don't need a new version yet, right? So let's try this again. Let's try this again. It should be up now. I'll try this again. Maybe. Yeah, now it started working. Okay, yeah, so this was a caching issue. Again, very good to encounter caching issues because they are going to happen, right? So if something doesn't work, check if that is a caching issue. Okay, so we have an extra column, all right? All right, so what we can do in data frame, we can get information what we have. So we have year as a number, trial number, and we have object. So what does object mean in terms of pandas? It means basically a string. It's just anything, you know, all kinds of data. This is something we probably want to do some cleanup. Maybe possibly convert to a numeric if it's possible. Here we have punishment and file name. We'll probably leave them as strings, and text also will probably stay as a string. But what we'll want to do is we'll want to do some cleaning. But first, let's check what our year and trial stats. What do we have actually, right? So year, well, we have 1,637 trials, right? So nothing's missing. Well, average year is 1823, maybe not very useful, but we know that the minimum year is 1720. We saw that's a book we looked in a previous session. And we know the latest last year is 1913. So it's in quartiles. So this is a very good way quick way in pandas to get some basic statistics out, right? And by default, the scribe will work on numeric columns, right? But if you remember correctly, that there was object columns. You can get some data on object columns as well, right? So let's take a look. We have file name, and well, we do learn some interesting things. First of all, as not shockingly, we have only 20 unique file names. It makes sense because we only had 20 files we worked with, right? So 20 file names are there, right? We see that the top, but we learned something new here, that 1821, what was it, December 5th, was quite productive, or I guess crime in that day was quite prevalent. It was most popular, 173 occurrences, trials that day. That means what? Let's count it. It's, let's say, 8 hours or 10 hours, 17 trials an hour, 4 minutes for a trial, right? Roughly. Quite speedy, right? It's just like a machine, I assume, right? So, yeah, okay. And okay, but also what we can learn also that we see the transportation C summary, right? So this actually is the most popular punishment. But we know, of course, that doesn't include just the planes transportation. This is probably which is the same punishment, right? There's an extra data here, right? So we'll probably want to combine these two. Would be a good practice. Text, of course, it's not shocking that there's 1,637 unique texts. This would be a good way of, if you have something more than one occurrence, it means you have duplicate texts, right? Which would be probably something you want to exclude, right? Duplicates. Right, okay, so let's do some simple analysis on what we have. First of all, we can get all of the text, I believe, right? Yeah, so let's take a look. So we have a text column, right? And what we can do is we can create a list out of this column, and we can join everything. So how much text do we have? Let's take a look. Yeah, this is the first text, right? And this is the last text, apparently, right? So we basically did this way of extracting all of this text, all different rows. You can just, with this recipe, you can combine it, the data. and you can get full text back, right? As one single big massive string, right? So again, we joined each item, each cell, textual cell with a space, and we got the full text. So, okay, that's how you could get, one of the approaches how you could get a full text, if you need to, right? So we have about 5 million characters in there. Yeah, so we could count, of course, we have full text. We could do some basic analysis here already, see which are the most common. Not shockingly, space is most common. Well, I would say, no, not shockingly, it's not normal text, there space would not be probably most common. We'll see, because we didn't actually clean all the extra white space, I don't think so. Also, but we do see, if you remember your Sherlock Holmes, right, E was the most common letter in English, right, which is the case. So we could compare this against your expected values, but we can see that E was present the most of the letters, right? What's interesting is I don't see much punctuation here. Did I clean the punctuation, or it's not present? Well, let's do most top 30, right? And by now, let's do, again, we know this trick, right? Let's do this. On separate a new line, right? Sep new line, right? And let's see this. Yeah, on the E, T, O, so there's comma, there's dot, right, okay, yeah, it makes sense, but yeah, this I think is quite, that's like, I think there's too much white space. So that's how counter, this is built in Python from collections, a simple way of counting pretty much anything, right? If you have some sort of sequence of anything, you can count it, and you get frequencies, very nice. Okay, now if you want to get all our counter, right, we can create a new data frame, right? And we create we say from dictionary, because what the counter is simply a dictionary with some extra benefits. So a counter has a key value, we have some extra methods. And as I remember, Pandas really likes dictionaries as a data source. So I rename the columns, symbol, and count, and we have our data frame. But what's different here is that it's not sorted. We probably want to sort this, right? We could sort it. Yeah, exactly. We say we want by count, right? And also notice something here. In place true. What does that mean? That means I'm going to modify this. So this means in place will modify the data frame, right? Again, AI knows what I'm writing, right? What I meant to write. So it writes comments for me, basically, right? So that's one of the advantages since Copilot, I think I write, I don't know, 5 times as many comments before, right? So I like to think that my code is more readable, more understandable from that. So we'll see the top 25. And yes, indeed, white space is present. Okay, you notice here, this is the index in the data frame, again, which we usually drop if it does not mean anything, right? In this case, also, again, it doesn't mean. We could have, of course, made index symbol, right? That's also possible. Here, it kind of makes sense. Yeah. And I guess it's time for a small, tiny visualization. Pandas comes built-in with built-in support for matplotlib. Some of you probably have used matplotlib, right? So default plotter is matplotlib, and you just say head. Well, depends how many items you want. I want the top 50, right? And I say plot bar. I say what's x, what's y, how big is the picture. There's some other properties we can read. What else can you do? Color, some other properties, but for now we'll use these basic ones, since we're doing the exploratory text analysis. And yeah, we have, of course, this nice, well, I wouldn't say it nice, but it's at least give you some visual idea of what's happening, right? So it turns out we have 100 unique items. Length, because again, it makes sense. We counted how many times each item was present, so a total we have 100. Let's do a tail. We can do a tail. Last 25, right? The least used items. Look at these, right? Look at all this weirdness. Well, not all weird, but this one looks weird. This looks like Old English, I think, right? And there's some, this is obviously not English. So there are a couple of theories. I think this is, well, not umlaut. This is what? Yeah. And most likely I would say it's most likely a OCR error, possibly. Or maybe there was actually a writing. Maybe somebody had the last name. Who knows, right? So you could check it out. And also we have some other very, most likely not part of the language. For some reason, there's $1 sign. Yeah, maybe there was an American on trial. I don't know. Or maybe it was... right, so let's plot that. Let's plot this tail. So in this case, the recipe doesn't change except we give a different data frame. So what's happening here is, so notice, so when we give tail, it is a data frame. Yeah, you see? So what's happening? We have some sort of data frame. It's very common in pandas to chain your operations or methods. So I could skip this. If I didn't have tail, I would plot everything, right? So I say, okay, I want just the last 25 tail. I have plot method, right? And I call bar method on that. So it's kind of nice, I think, relatively descriptive one-liner, right, on what we are doing. So we get the tail from the last 25 items of data frame, we plot it and bar, and then we supply the parameters. And we should see something. Yeah, so these are the least likely items, right? Again, yeah. Yeah, I was mentioning here that this 100 seems a little bit suspicious. Yeah, but that's something I want to be maybe a little bit suspicious. Okay, but yeah, so let's double check. I'll show you another recipe. If you have a data frame and you want to create a new column based on some other column, one of the better approaches is to use an apply method. So, okay, I'm saying I have a symbol, right? Symbol column. It has some value, right? What this says is that I am going to create a Unicode new column, and for each entry here, I'm going to apply an ORD function. What's an ORD function? I'll show you. So, ORD function, right? ORD function returns the Unicode code of the character. For example, print ORD A. So what's A is going to be 80 something. Let's take a look. 97, yeah. So again, because also ASCII. Yeah, English letters, the Unicode values. Let's see, ASCII table. I'll show you ASCII table. Yeah, let's see. Yeah, you can see here. Notice how I just start typing and AI picks up on what I'm trying to do, right? So this is from, like, I think 1972, and actually it goes back even older. I think even before computers. I think teletypes, which were like 1930s, I believe, right? So that's how it evolved, right? It's still the same numbers, right? Up for English, right? So all these numbers up to 127 are the same. Afterwards, you have Unicode. So Unicode is good because it involves all languages: Latvian, Chinese, Martian, I don't know, right? Emojis, right, are included. So, but yeah, so here there's an ORD function. So this is an example of how I can create a new column by using existing function. Now, of course, that requires, in this particular case, to work without any errors, that this actually is a single character. I don't know what's going to happen if I forget now what happens if I have multiple, say Valdis. I don't think it will work. We can try, but it shouldn't. All right? Or Valdis, I think it will not work. I forget now. Yeah, it's an error. Type error because expect a character, but string of length 6. So what I would do, this won't work. Okay, sorry. What I'll do is I'll show you how I try, right? Yeah, this will fail. AI does my documentation for accept exception as E, and basically we'll get an exception. Yeah, so we get the error here. So this is what we catch the error. Yeah, okay. Right. So let's do this. Apply. That I'm showing you because in order to show you how you can make a new column out of existing columns. Okay. Right. So we can check. We can apply a filter to find which are symbols in our table which are over 127. Right. What does this mean? This means non-ASCII symbols, right? So presumably for the English corpus, this is not something we need, right? Again, it depends on your needs for your analysis, but we assume for this workshop, we are going to basically get rid of it. Right, so let's take a look at this. Over 27, and we have, how many? We have 13 non-ASCII symbols, right? Okay, what are they? So this is what you call in English, in Latvian, defisne, long dash, but not a small dash. M dash, okay, yeah. Of course, they have pound symbol, right? So long dash, this pound is used quite a bit. This looks like somebody died, I guess, right? Death, I assume, right? And, yeah, so these are all the English ones. Right, but they are very, very few. So basically, for purpose of this, we'll get rid of all of it, right? But again, of course, you have to think, do we really need this dash? Maybe you don't. Do you need it or not? Right. So note also how some nice long triple dots. It actually has a Unicode symbol. It's seldom used, but it exists, right? So it has a Unicode 8230 symbol number, right? So it's just not 3 dots. It's actually one character. Okay, so we can count how many of these are, but this is just the same thing we did before. We know that this dash is present the most. Right, so we have some strange symbols. So let's, again, I'm not a specialist in Old English, right? So I see some of them are part of the old alphabet, right? And maybe some of them are artifacts of OCR process, which of course can happen. Right, so let's get rid of all this extra white space. So now we're going to clean up this text. Let's make a function to replace all white space with a single white space. So this is one way of doing it. So I have a function, replace white space. I give it some text, right? And it's going to look using regular expressions for any one or more white spaces. So this means tab, new line, right? And it will replace it in this case with a single white space, right? Okay. I will add this actually, well, yeah. So I made AI, so who knows what I did here? I added type hints. Yeah, type hints, I said, okay, in Python is loosely typed, meaning it does not enforce this. It makes Python very easy to use. But if you're writing a bigger project, this lack of these hints might lead to some hard to catch bugs, right? You're giving it some wrong type, right? So what's happening is there are tools to pick up on these hints, but not Python itself. Python itself is not going to ignore whatever you wrote here, actually, right? There are so-called linters which will pick up on this. But so yeah, but it's good practice to actually, if you have what you expect to see. So here in comes string, out comes string, right? It's pretty much obvious, right? So okay, so now we test it. I gave it this bunch of extra white space, and you see that all the extra white space is gone. So simple function. How else could we do this? Well, we could do it also with regular replace, but be harder. So this is basically, again, so this is regular expression. S means any white space, right? One or more. One more mention. So notice here this part, this R. So that stands for raw string. Why did I use it? Yes. Yes. So basically, because regular expressions has escape. Like this is escape for regular expressions. If I did not use, if I didn't use raw string, just regular string, I would have to escape it twice. right? I have to escape the backslash, and then it itself is used as backslash. So I have to escape it for the Python string, and then it would be used for regular expressions. So if you are using regular expressions, you most likely want to use raw strings just to save yourself the headache of multiple, triple or quadruple, sometimes backslashes. Sometimes it'll get really unreadable. It's already, regular expressions already can get quite hairy, but if you didn't have this, it would be, I had to add extra backslash. So R is not regular, this is not regular expression, this is raw. So this means no escaping, no special characters, as it is, right? So by now I mentioned this to you, that this apply function, right? So what we can do this, before we used odd, right? We used odd function, which is a built-in Python function, which takes some single character and returns the number, right? And we use that to apply here, apply this column, we create a new column name, we apply to an existing column this function odd. What we are going to do right now, we're going to apply it to the text column our own function. We're going to apply our own function, right? In effect, we are going to be writing a for loop, but it's much more efficient than writing a for loop and going through rows. So we start cleaning, and I'll make it clean text, for example, maybe a clean text. Right? To see this is of course quite wasteful, right? Yeah. So, well, I guess I'll replace it. Yeah. So, and maybe let's do a length of full text. No, full text join. No, that's not going to do it. Let's take a look. I'm going to comment this out for now. I remember I want the string as a string, right? Oh. It was full text equals what? Join. Yeah. Length. Yeah. Let's try this. Yeah, so 5 million, I think the same one, right? Okay, right? And now let's do a cleaning and let's see what happens, right? I'll move it around. So since I'm doing a timestamp, right, I want to see how long it takes, right? Control Z, right? So I just take a snapshot, I just make a full text, save copy of the text, and now if you have a really long, large data frame, maybe 50,000, it might take a while, a couple minutes maybe, slower computer. It's still fast enough because it's in your computer memory. It should be fast enough. It's not a complex operation, but it might take a little bit. So, and cleaning, and now size after. So now I say size after, right? After cleaning, I'm using AI assistance right now. It's going to do it for me. Look at this, full text again. The AI, the Copilot picks up, okay, I want to do a full text. So obviously I need to remake this variable, right? Because copy the new contents, right? And then print full text after cleaning. After cleaning. Yeah. Okay. Now let's take a look on the datetime. Okay, let's take a look now. Did I make mistake? Yes, it worked fine, right? You see, so we got rid of about 160,000 white space characters using this, right? And in this case, I overwrote. So my original white space is gone. If you are not quite sure, I would recommend doing it first on a column which is don't overwrite the old column, right? Make a new column first, right? If you're kind of like still practicing, right? So otherwise you'll have to load the data again and do all the steps again, right? So does it work for you guys? Yeah. Okay. Now let's do this again. So I'm going to make a function that takes a data frame on the name of the column, right? And gets full text from the column and returns a counter and returns a new data frame with this counter. Right, maybe I should also sort by sort, or maybe sort index, sort values by column name, I think, right? Column name? No. No, I forget now what's going to be. What's the name of the column? Count by, I think count. Let's take a look. I'm guessing it, but let's take a look what happens. Oh, yeah. No, I did make a mistake here. There's no such thing as count column, I believe, right? Yeah, there's no key error. Let's see. I think it's just called one. I think it's called one. Let's take a look. No. Let's see, or by 0, but let's take a look. Yeah, by 0. Okay, I guess so. Let's take a look now.
You have to say in place true as well.
No, well, okay. No, here's the thing. Okay, what's happening here? I'm not I'm returning a new data frame here, so I don't need in place here, right? Because I'm doing it on the fly, basically, right? So I could have done it here if I wanted maybe a bit more. Maybe do it over many lines, right? If you're just still learning, you could do this this operation, and there's 1, 2, 3 operations in one line, right? So this is again chaining these operations. You could do this one line by line if you want, right? So yeah, so this 0, so 0 refers to the key of the dictionary, right? So because again, so yeah, now. So counter, and I was asking, is anything missing here? I wonder here. Okay, full text. Okay, all right. So the only thing in it. So yeah, here's a question actually, right? We get the full text. Yeah. So what's happening? Yeah, that's kind of a little bit of trick question here, right? So what's going on here? Right. So who can tell me what's the issue? Yeah, this is the question, trick question here. But what's going on here? What's maybe not quite correct, or what's going on here in this line? What's going to give us maybe not quite correct data? Artist probably knows. Yeah, what's missing? What's maybe extra something? What's giving me? Well, let's look at the results, right? We know the white space is winning again, right? And it's not really, I guess, not too surprising. There's still a lot of white space. But what's happening here in this line, right? Well, I'm creating a new full text, but I'm joining by white space, right? So basically, in effect, how many rows? I had like 1,600 rows. So I'm adding 1,636, like, right, white spaces, right? So if I'm counting only single characters, then I probably don't need the white space. If I was trying to create tokens of full text, then I need this white space, right? Because I'm going to be splitting probably later on. So here I probably want to get rid of this, right? So I expect we have 3841, right? I expect it should be about 2,000 something, right? Let's take a look if that's the case. It is 2,205, right? So about 1,600 less. So these are kind of little things you can miss sometimes if you are just, going, maybe doing it on AI assistance or just doing it by copy pasting some code, right? So we just join. This just joins all different list of different texts by nothing, right? So Valdis ends and Riga follows, right? There's no white space, right? If I'm counting characters, that makes sense. If I'm counting words, then I need the white space, right? So, okay, so I'll leave this for next class. But you guys got the idea, right? Yeah, all right. So, now let's go back to our DF, right? I have my DF, right? So now let's clean this, right? So this is now cleaner. Yeah. So did I clean this? Right. So no. Oh, did I call this? Yeah, I did call it. Right. I can, of course, but if I do it again, it will not. If I do this again, I can do it over, but it's not going to change anything, right? It's 522598. I expect to stay the same, right? Let's run it over again. Yeah, it stays the same, right? And I should be able to, it would be a bad sign if there's something changed because it's already clean as much as it could. Right. So now the question is, how did I save it? It's still, where is my df? Yeah, okay, text, apply, replace, okay. Now let's take a look at head. I'm trying to see, oh no, this looks okay, but I'm trying, why is there, it looks like Alice there's lots of extra white space for some reason to me. I'm not quite sure why that's the case. Maybe I didn't, no, I should be working. Okay, let's take a look at this. I'll show you how AI would work. Let's get text from second row. And we want the first 100 characters. Let's take a look how it will handle this task, right? So yeah, df text 1. Let's take a look. Yeah, it's fine, right? It's fine. So you get second row, right? And you get the first 100 characters, right? All right. So again, AI is able to pick up, Copilot is able to figure this out by itself, right? But again, so now we want to save this. We're going to save it as cleaned, right? Temp folder again still, right? And again, no index column, right? We already know this from the previous lecture, from previous session, how to save it, right? If this does not exist, if this folder does not exist, right? Another tip, of course, if you're working with notebooks, try to make them a little bit better in each iteration. Right, so now we have raw text. We save this. Now we want the analysis, but we need to decide, do we want to remove punctuation? Right, if you're going to do, of course, you're going to analyze punctuation, it would be kind of silly to remove it, right? If you're going to see how, punctuation was used. But usually in text processing, usually we remove punctuation. Well, a couple of reasons for this. Well, one of the reasons is that maybe it's part of the word, maybe the comma is part of it, or a dot. I mean, it's part of the word, it's not separated, right? So it would just, ruin the analysis, basically, right? So it's easiest is to just remove it. Yeah. Now, if you are going to be doing sentence level analysis, you probably want the punctuation. You most likely want the punctuation, because how else are you going to tell what the sentence is, right? So it's not like reading the Bible. I think if you ancient Hebrews, they don't have punctuation. I think it's just one big ball of text, right? So sometimes you have multiple interpretations, right? So we will remove punctuation. We have this is included in Python, right? This comes with Python, yeah. But what we are going to do, right? So this is what's included in Python, and this is what we found, right? These are all other items. So we are going to join these together, right? So we're going to join our bad characters, right? And this next recipe is how you replace. You have a whole bunch of sequence of things you want to replace. How to do this all at once. So what you do is, one thing is you could make a loop and go through one by one. That's completely fine. Replace each one, right? But more Pythonic and more elegant, there is something called make translation, right? So we create a table, right? So we create a translation dictionary. You have bad characters and what you want to replace them with. Maybe you want to replace them with X, maybe with white space, or maybe with nothing. In this case, nothing. So we have a dictionary of things we want to replace. what's interesting is it's going to be, I believe, let's see, 33 is okay, all the text, translate table, right, 60, okay, yeah, okay, so 33, 34, 35, okay, yeah, so these are all punctuation, so these are what? These keys are Unicode numbers, right? So 33, I believe I have my ASCII code somewhere here. Where's my ASCII code? I forget now. Oh, there we go, right? In the table, that would be somewhere, yeah, exclam. Exclam is 33, right? And so on, right? So, let's do this. So this is, we have prepared dictionary. You could do this by hand, of course. You know, just a Unicode, what you want to replace. So basically, we're going to be feeding a dictionary of items we want to replace. On, right? We find that there, we're going to apply how many items we have, how many text apply length. So how many characters we have before. So how much was it for each trial, how many characters were present, right? So I'll create a new column, right? And maybe I'll move this so you can see what's happening here. Yeah, so I said, okay, so this line here, I said, create a new column, dirty length, that's my name, and use length function to each item from here. So this is 705, this is 1087, 904, 804, and so on. So again, we supply the function. So this is so-called functional programming, right? When you supply a function to something, basically, to another method, basically, here in this case. Right, so we have 5283954 characters total without white space. Okay, so I want to see how much clean length is afterwards. Right, so translate text. We are going to supply a function to remove all the extra dirty stuff, all the extra characters we don't need. In this case, it's very easy. So in comes text, right? In comes text, nothing too strange, right? And out comes also text, right? And we are using translate. Replace each character in the string using the given translation table, right? So this is a dictionary, so translation table. So translation. Yeah, we already saw what it looks like, so Unicode and whatever you want to replace. If you don't want only completely get rid of it, I mean, you could make your table here, right? You could come up with some other items, maybe 36 needs to be 3 V's or 3 A's or something, right? So this is also slightly faster than writing a loop. Okay, so let's do cleaning. And we are going to see how long it takes. It should take maybe like 1 second, pretty fast. We have 5 million characters in 1 second, not too bad, right? And yeah, so slightly less than a second. Now let's think about if it's 1 second for 5 million, if you have maybe like that's 5 megabytes roughly of data, roughly actually. So if you have like maybe billion, so that would be 5 million, that's like 200 times slower. So it's about 3 minutes to clean 1 gigabyte of text, basically. Very rough, right? I'm skipping the data types, but roughly, yeah. So it's not too bad. You can clean pretty large amount of data with this translation. So pretty fast. And this is not the latest computer. So, okay. So now I want to compare it, right? I want to see what's happened. So yeah, 506. So we cleaned about 400,000 characters roughly, right? So again, I went through a column and I sum all the values, right? It's a sum of, right? So I have dirty, clean. We can see, we could also, if we are really bored, we could analyze which trial got cleaned the most and things like that, right? So now we have our clean text. We know how long was the dirty text, but we could also probably normalize, right? So we can see, yeah, we removed 200,000. Okay, right? 200,000. Okay, let's do it again. Temp file. Saving, saving to file, right? Yeah, so now it's cleaned up. Again, I'm not submitting the changes. So now we get to the cleaning part, to tokenization already. We already can almost start working. Let's do some tokenization. So what's tokenization? Means creating, well, tokens, right? So what's a token? It's a unit. Bless you. So is the word? Well, not necessarily. For example, ChatGPT, the most large language models, they use less than a word. They use the tokens are about, well, roughly half, less than half a word, actually. So it depends what you're trying to analyze. If you're analyzing sentences by themselves, the token might be just a sentence, right? But here we will do word level tokenization, meaning we want to get the words out. Okay. Right. So first I will do, again, I mentioned already this before, normalization. This means lowercase in this case, right? We don't care about uppercase, lowercase differences. Depends on language. Sometimes it's important if you have, proper nouns, they match in Latvian. What would be an example of Latvian proper noun which matches liepa? Yes. Yeah, liepa is a tree, but also could be last name, right? That's what you meant, right? Yeah. Okay, yeah. So depends on your language also, right? But generally it is, right? So we are going to lowercase all the text. This is very simple. Basically, in this case, you don't even need apply. We could use apply here, but it's built in pandas, right? Simple. So we say, we take our text column, and we actually overwrite this. Here we could have a new column, but we just overwrite the old one, right? And it's all lowercase. It should be pretty quick. And we can check uppercase. This function checks if there's any uppercase symbols, and there are none. So there's no uppercase. I mean, it's not surprising because we just lowercased everything, right? So, but again, I am sometimes slightly paranoid. Sometimes you forget to do something, and you want to check your assumptions from time to time. It turns out you're doing analysis, and you skipped a step sometimes, right? It's especially easy with notebooks because you might have some cells and you skipped a cell. Maybe you didn't do run all, you did cell, and you skipped one cell, and you're working still with relatively dirty data. You still have some punctuation, or you have uppercase or something else, right? So it's good to check from time to time what you have. Now, so let's move on to tokenization, right? We can treat them as a group. So in this case, we're going to probably do words. Most common way, of course, is using split. So how does the text, this is the default version of split. You take income string, outcome comes what? What comes? List, list of words, right? List of text, list of strings, right? So by default, it uses any number of white space. So you have 5 white space or 600 white spaces, it's gonna do it one, right? So you're gonna lose this information by splitting, of course, right? So in case we actually we already did all this extra work, we don't have any extra white space, by the way. But in this case, it doesn't matter. We can split. I should mention again, so split has extra, you don't have to split by white space. You can supply custom split characters, right? But for now, we use this. And as you remember, right, we could check also multiple white spaces. Let's do this. First, we'll make a function. We're going to check, do we have anything, right? Right? Do we have any? Just check. There, oh no. Oh, we do have some white space. Let's see what's happening. So at least 2 or more. I wonder, why is that? That's because we didn't replace something? Because we changed all in one big string. Yeah, we used Yes, we added spaces. Okay. Yes, again. So it's a good catch actually here, but we could do it with regex. By the way, 2. Let's remove it again. Yeah. So 2 or more, right? 2 or more, right? Again, raw string, and we can clean it again. and we can check. It should be clean. Yeah, 0 white space, right? Again, this stands for any white space, right? So this means tab, new line, carriage return, space, white space, right? So, again, so what we'll do is, again, in this case, very simple. It's text split function. Again, I'm showing you this way. You could make something more complex here, right? But here, in comes text, out comes text split. So we're going to do it again, apply, right? And here, yes, I could use this approach, right? Which is completely fine. So I don't even need this function. But I will show you another way. If this is so simple, if it's a very short function, right? In comes something, out comes something. You can use this so-called lambda function. What's lambda stand for here? This stands for what kind of function? Anonymous, yeah. So meaning function is no name. Because apply needs a function. It expects a function. And if I'm too lazy to write a function out of this, right, I'm going to, comment this, right? I can write it myself. So, T or text or whatever, or A or X, but text is good, right? Short, but not too short. On, out. So in comes text, out comes text split, right? So this is a famous lambda, and it's nothing more than an anonymous function in this case. So if you have longer, if you need to do something complicated, you should write your own function, because long lambda is going to be hard to read, right? But for short, lambda is completely fine.
You don't even need a function here.
Yes.
You use the string accessor and then split.
Yes, exactly. So let's try that actually. It's a good catch. So that should be happening here because it's we could even use split directly. Yeah. I think this should work, right? Yeah. This should work. This is probably the best way in this particular case because it's the shortest way. And there's no extra, you don't need this lambda, you don't need the extra function. No, we're just splitting, right? That should be probably the best. Probably I wouldn't say it's the best, easiest to read, I think. Yeah, I think. Well, speed-wise, I think it's roughly the same. But let's see what happens. Words. And right now, yeah, we have an object. Let's take a look. So we got something, right? Right, it's an object, right? So let's take a head. And we have a list of words, right? So I'm probably going to, yeah, exactly what I'm going to do. I'm going to create a new function, word count length. I think we can do it actually. Can we do it with string length? No, I think so. Yeah, let's do that again. Yeah, because I was using apply to kind of sort of like to show you how easy it is to use apply, but maybe you can do it directly. We could even skip this, yes, and we could do it directly. We could skip apply and just use string length function directly. So it should, yeah. But again, the main thing, I don't even show you this in this course. There is something called iter rows, and that should be avoided if possible, because it's much slower if you go through row by row, those type of functions. If you find writing for loops in pandas, that means you probably went wrong, because that means it's not going to be efficient, right? You might not see this in 1,000 rows, but if you have 1,000,000 rows, you will definitely notice, right? Generally, you want to do something at once, basically, on a whole column or multiple columns. Okay, so let's take a look now, and we should see the word count. Now we have, yes, so 129 words, 200 words, and so on and so on and so on, right? So we have some new data. All right, so we're getting close to finish for today. So now we have our words. Next thing is probably stop words. And then this is another place where you should probably talk with yourself or talk with your supervisor or your colleagues, see if you actually, or your called stakeholders, right, whether stop words are going to be needed here, right? So what stop words basically, and things which are very common, they don't provide much extra context, and generally they are just going to be slowing down your analysis. Again, of course, if you're studying stop words, you want to keep them, right? So this part here is probably not gonna work for some of you, because what's happening is you will need to load the English core web small, I think small one, I think it was SM. What does SM stands for? I forget now. I think it's small model. I think it's a small model. Yeah, right. So we'll get all the some from Spacey. It comes with this. Of course, you don't have to get from Spacey. You can have your own list of words, right? So we'll load it and stop word. It has a stop words. Let's see how many. Will it work? Yeah, I think it will work. Why didn't it work? Why did print stop words length? Maybe too much output. Oh no, here it is. Right. So 326. So this one could other ors none anyhow since moreover much. Yeah. So there are other lists of stop words. I'll show you what sklearn has. Scikit-learn. This also has English stop words, right? Let's see what it has. And what we could do is, right? Yeah, and we can compare them, right? So see, again, this is going to be set operations. Sets are great data structures, maybe less used than other structures in Python, but quite useful. So what we want to do is, which are common? We have two sets of stop words. We want to see which ones are common in these two different sets, right? So we do an intersection, a Venn diagram, the middle part, right? And we have the stop words from the Spacey, from the scikit-learn, and how many are there? 291. So how many were originally? 326. So almost, there's a pretty big overlap, right? So I guess we'll use these. So if two different libraries say, okay, these 291 words are completely not useful, right? We're going to remove these, right? Of course, again, you could use different lists. Maybe you have your own custom list, right? You get some other ones. So this one here, I'm trying to see if this is actually, again, apply approach. Let's see. I want to mention this. This is an important point. That this recipe, right? So in comes a list of words, right? And I am, common stop words. I will do this. But I'll supply a default function here. Actually, this will be better, right? Because maybe I need to have different words. So basically, in comes some words. I'm only returning the words which are not present in this bad word list. Not list, set. And this is by the important point. This is one of the sort of like common mistakes in terms of efficiency. You're checking for something in a list. Checking for items in a list is slow. You have to go through the whole list, basically, if something is present. Checking whether something is in a set is extremely fast. It's so-called O1 operation, meaning if you have a million items in a set, you can check immediately. Basically, it's using a hash value, you can check immediately. If you're checking for a list, you have a million item list, you'll have to go through all the items in the list, check whether something exists. Right, so this is, if you need to do this type of operation over and over, it might make sense to spend time to make this set, right? You make set once, and then you use that to check. Okay, there's something to consider. Now, again, I'm going to use apply here in this type, right? There's some other methods, but apply is, I think, easiest here, right? So remove stop words, start cleaning. So we have words column, and I'm going to overwrite this again, words. Or I could, of course, do a clean words, a new column if I wanted to, right? It should be pretty quick, right? So let's do a count. And it's pretty quick, 0.1 seconds. Yeah, because we use a common. Let's take a look here. So we had 129, 66, 287, right? So about half are stop words, right? Roughly. We could, by the way, let me show you one more recipe to show you how you can use two columns. We could proportion. Let's create a new column, proportion of clean words to original, right? So look at this example, right? In pandas, you do need to operation on multiple columns, right? So you take, in this case, it's a proportion. You take one column, another column. Of course, in this case, you need to have the same data type which allows division, right? And hopefully there's no zero. That's the purpose. Maybe there's one column, it's possibilities there's going to be a non-value 0, right? Yeah, maybe division by 0. Let's take a look. Are there any nuns? Yeah. Let's see how many nuns. I don't think so, maybe. Let's see first. Right. Let's see the first 5 rows. It's so common because df head. I do it so often, so the model has learned that I expect to do this, right? So it's almost expecting to write this at the end of this data frame. So, yeah, looks like there's nothing divided by 0. It would not be end of the world, but just something I can double check, right? So it looks like at least we have at all the trials. These trials have at least one word or more, right? We could do filtering, we could do some analysis, how long, maybe we'll do that actually here. We have 15 minutes, so maybe we could do this for next day. Right, so lemmatization stemming. Right, so two different things, but related. So stemming is we have the root form, right? So running, runs, run, right? But it is a little bit careful, right? Caring, care, right? Carrying, right? So we have we might be stemming too much, maybe, right? So it's a little bit a tricky process, actually. Sometimes it's not ambiguous. I mean, sometimes it's ambiguous, actually, right? Especially in Latvian, right? I don't know about other languages. Lemmatization is different because we're reducing the words to the lemma a dictionary form. So MR is going to be, the lemma is going to be, right? Again, in Latvian we have thesaurus, right? So where we can check this, right? So lemmatization is usually more accurate, right? But we probably also, it might do completely accurate. It needs some morphological analysis, right? Because you have some words, but the context, what's happening around. So, but we are lucky. In this workshop, we're using English, so they have pretty good algorithms for this, but better than nothing. So let's take a look. So so this is easy. For word lemma, let's see this recipe. Bless you. But yeah, so for word in NLP, join words. So it's going to create, basically what they do is NLP comes from Spacey, right? So it's going to join, or it's going to process this, make an object, right? And then we're going through for each object, for each token, or in this case it's a word, we'll get its lemma, right? For each. So let's take a look at this, if this works actually. Words lemmatized. Let's see how long it takes. It took me a while. It took me 45 seconds here. Let's see, last time, yeah, about 30 seconds. Let's do that. Why not? If I have power. Yeah, okay, looks like good. Sometimes for longer operations, you can see if you turned off power, or maybe your laptop is in an energy saving mode, it will go slower, obviously, right? It's a good way of finding if your computer is actually running at full power. We can check what's happening. CPU, at least one core should be doing some extra work. Which one it is? Maybe a couple of them. Like I said, it's not a very new computer, but it's working. Yeah, there are some cores working. One core, actually. But yeah, should be over soon. 45. Yes, this would be good. Actually, I wonder how good idea how to click add this, because, well, if you do the iter rows approach, we could apply TQDM, right? But it would be much slower. Yes, I think there is one. That may be a good approach, actually, because for some reason it's going slower. I did this yesterday. It took about a minute. Now it's more. I wonder why. Because again, it's not just a simple dictionary lookup, right? It's a little bit more. Yeah, this would be good actually. This is big, and I've used this sometime. The progress bar. There's a way to do this. Okay, took longer, right. So now,
Yeah, instead of apply, you use progress underscore.
let's do this. So Shift Alt, right. So, well, I'm not gonna. So progress.
Progress underscore apply, but you have to import TQDM first.
Yes. Okay. I think I thought. Yeah, this one. Yeah, progress apply. So I need, of course, I would need to. Well, I could import here. Well, very good, very good. This one I remembered using this. I guess I'll import. Well, generally you should import it from. Do we need from import or just?
I think it's from TQDM.
Yeah, that's what I would do. That's what I usually do. TQDM, import TQDM. I think so. Yeah, let's see if this works. All right.
And you also have to
Options.
initialize TQDM.pandas,
Yeah.
and then it should work.
Yeah, this one. Yes, you see, AI knows this. AI knows. It told me exactly, right? Yeah, very good. Okay, so we could see how slow this is working. Right, next time we'll see the progress. Obviously, this is best to import at the beginning, of course. Yeah, of course. But so this I won't run it again. But we know this. It worked. So now we should see the lemmas. Where are they? Words lemmatized. Okay. Words. So is cheap. Indict. You see, yeah, it works. Feloniously. So indict. We should see them here. Indict again. Right. Of course, all these proper names. It looks like they're not under. Yeah. In English, it's easier. Right. So let's take a look. Yeah. So let's see how many words. What's our word count in general? We do iter tools. We are going to get all words and see how many are unique. Unique lemmatized. So basically what I'll do is I'll compare how many words we have and how many lemmatized words we have. We expect that we should have less lemmatized words because, of course, different versions of same word will have same lemma, right? So let's see how many. 22,000 before, 19 after. And yeah, it's still the same. So it makes sense. This is time from Shakespeare. No, well, after Shakespeare, but apparently trials use not much. The vocabulary was quite limited, right? So 22,000, right? I mean, I think a good English, writer would probably use 40,000 words. Of course, the English vocabulary is quite a bit bigger than that. So, again, it's something I usually check. If something, we have a corpus in Latvian, we have 500,000 lemma because, of course, we have lots of extra special symbols, which doesn't match the language itself, right? So, okay, so we did lemmatization and stemming, and it was not so different. Again, in Spanish, might be different. You might need to find also check the support. If you want to do the spacey one, I'll show you. Check the spacey lemma. Let's do. Yeah, but language support. Yeah, so English has pretty good support, very, very good support. Language support. So check this out, right? So Catalan, Croatian, 3 packages, Dutch, English. But you check Lithuanian has pretty good. Latvian has just the basic one. There's no support. There's just, I think you can tokenize, but that's it, I think, right? So there's not much in there. So if your language, you can check here, right? If your language is on this list, here it probably has good support. If it's here somewhere, you just have very basic support. You could write a proposal, maybe do work yourself, add to this. Right, so and now let's save it, right? Let's save to CSV. Right, 13 megabytes now. Well, 13 megabytes is fine. this is completely fine still. GitHub has a limitation, a hard limit of 100 megabytes and 50 megabytes soft limit. So GitHub is not the best place to store files. That's actually an issue where to store large corpuses actually, right? I mean, I guess there's Kaggle. Maybe where do you guys store your big files? Anyone? Google Drive, yeah, that works. Yeah, OneDrive, well, yeah, whatever you provider you have, right? Yeah, that's the issue because with GitHub, well, what we do, of course, sometimes you want to store them on GitHub, so you chunk them. You chunk them, of course, and we have our programs for that, and then you can get by, right? Now, so this one might not be necessary, right? So if you want to import a Parquet, right, this usually is not necessary, this import PyArrow. But I think I think last time there was a bug for somebody who couldn't save to Parquet. Did it work for you right now? In the middle back, it works now. The Parquet yeah. Okay, great. All right, so that's good. So yeah. So this part I also mentioned. I change. This is a pass method, right? So temp file has a. Let me show you what temp file looks. Print temp file. Right. Right. So it has a CSV. So notice here again, you could do it by hand, replace CSV, but this pass does so pass handles, yeah. So you say, okay, I want different. If I want different suffix, I want Parquet suffix, it will do it, right? So let's see what happens. I think this. Can I skip this? I won't skip this. Will it yell at me? No, it works fine. Yeah, because I only have support in this. So it's saved. So 4.5, right? So it compresses, right? There's very set a compression itself, but it's much more efficient than saving a CSV, right? So that's why, again, Parquet is for larger data file, interchange. It's recommended. What's the downside to Parquet, of course, is it's binary format, so you can't read it. Right, you can't read with if you open your notepad, right? It's a binary format. So, okay, what else do we have here? What can we do before, or we can check what we have? Yeah, so we've done stemming formatization. Yeah, so a couple more things we can discuss. So for Latvian students and participants, there is a list of Latvian stop words at the GitHub. This is a different repository. But what's interesting, I think this was done like 8 years ago, and this was a Spanish person who did this. So you might want to add your own, basically, right? So this is a start raw, right? You can see a JSON, a text file, right? You can see all the Latvian words here, for example, right? It's a starting point if you need to get rid of step words, right? So also you need to think about what do you do with words that are not in dictionary, right? And sometimes you have some multiple lemmas, maybe different versions, right? So I mentioned, right, there's another library in Spanish, for Spanish, in Python, that NLTK, right? And usually it's widely used in teaching, but it is more, that's why it's used. It's more academic, but for production, it's not as not as easy for production, right? But it has better support for Latvian, for example, right? So, okay, we have a couple of more minutes. I want to plot, what do I want to plot? I wanted to plot the, I know I want to plot one more thing before we leave. Word counts, right? Let's describe, this is letter counts, right? And these are word counts, right? Let's count the word counts. Yeah, let's do that. Let's count. I'll do a new markdown. Plotting word counts, right? Let's plot word counts, right? It should be enough, right? Histogram 50 bins. Well, that's the problem with histograms, right? Word count clean. Do we have such a column? Yeah, okay. And word count, right? Let's take a look. Histograms are good to get again, because it's good to get an idea what's happening. Well, first, let's do a describe. First, let's describe. Or data frame again. No, objects we don't want. We just numeric only. Yeah, so trial number, nothing's missing. That's good to know. There's no none values. So word count clean, right? So we see how number is about over half, right? Average drop by half. Minimum 6. So the smallest trial was 6 words left. So what it was must be very concise. Longest is only, well, longest is not 11,000. Must be a really long trial. I think we'll probably look at this tomorrow. The long trial, there was some serious, it is a big trial, I guess. So 11,000 words. Okay, let's plot it. So let's plot it. Well, 50, yeah, the quick one, right? I personally like plotting with Plotly, actually, right? It's much nicer, right? But we'll talk about this tomorrow. About the Plotly visualization. Let's see if we can do this with Plotly. Let's plot the same thing with Plotly. Same histogram with Plotly. Yeah, also logarithmic scale might be a good idea, right? Let's take a look. Fig show. Right, this is why AI Assistant is so great, because while even if I'm familiar with this library, it looks okay, right? I don't have to worry about this looking up documentation. It's so much faster. So what's the advantage of this approach is that Plotly is interactive, right? I can do this. I can zoom in. I can download. I have a panning. I have some extra functionality. It's basically interactive graph. Let's do one more thing before we leave. Let's do a logarithmic graph. Let's do log scale on y-axis, right? So simple. Log y is true, right? That's an option, and that's all I have to do, right? 3 years ago, I would have to go to Plotly documentation. I have to look up the parameters and see which one is one. Right now, I have a pretty high chance that Copilot will figure out this automatically, right? And of course, sometimes it misses things. Sometimes if the library changes, like maybe it only happened like 6 months ago, it might have the wrong setting, right? So you have to pay attention, but now it's log-based, right? So you can see, right? So again, obviously we can see this bin here from 0 to 499. That's the most common. The short trials are the norm, right? And only have this one super long trial. Okay, so that's something to consider, right? So, so Plotly is a great library. If you do not have Plotly, yeah, pip install Plotly, right? Okay, now that's it for today. Tomorrow we'll do some more modeling and some visualizations. Any questions on today's part? Were you able to follow? How about those who are relatively new to Python or notebooks? We're okay? So again, if something was not clear, I would recommend going through this notebook again, seeing the section which was not maybe clear, right? Go it over. Again, it's meant to be so you can write it over and over again, right? So I will add these changes to this notebook. Added some visualizations. So how about Zoom section? Any questions from Zoom? No. Okay, good. Are there people alive in the Zoom section? The question is no. Raise your hands. Yes. Okay, good. All right. So I'll see you guys tomorrow. All right. Thank you, everyone. What I was going to say, I might also add the screen. I record this for my own use. I might add them to the videos of these sessions if there's any interest of those. There might be. Yes. Okay. I will add those. I'll provide the link to those. That's separate from the ones provided by the conference. It'll be just my screen, what we did. All right, so thank you, everyone.